Notes are for integrated 2, 8.3.2. We're going to be talking specifically about ratios of similarity. So we have a couple of different ratios we're going to be talking about. Side length ratio, which I think we know from doing similar triangles previously. Perimeter ratio and the area ratio. So we know that our perimeter ratio of similar figures, so perimeter ratio and the side ratio are exactly the same thing. It's actually kind of nice. Now, just to be clear, the side ratio can be called a whole bunch of different things. It can be called the linear scale factor, ratio of similarity. It's called a zoom factor. It's a whole bunch of different things. Okay, then we have this area ratio. Well, the area ratio is the side ratio squared, which I think makes sense. So you guys know I have all those little tricks to remind myself of things. So if I go back to perimeter ratio, I know that the units on a perimeter answer are just straight units. I also know the units on a side length are just units. Notice that those are the exact same thing. That's how I remember the ratio between perimeter and side. They both have the same units on it. All right, well, let's think about what happens with area. So for an area ratio, I know that the units on area is units squared. Oh, I can see got the same thing here. So the side ratio is units. But if we square it, we would get area. So that helps me out. And then when I do volume, which you guys will do in the future, not in this class, then I would say that the volume comparison, well, units on volume is units cubed. So it's the side ratio cubed. It's actually kind of nice. All right, so we've got this shape. We're being told which ones are, that the two shapes are similar to each other. So if we have the ratio of similarity is 2/3. Okay, remember the ratio of similarity is another name for the linear scale factor. It's also the same as the zoom factor. It's also the ratio of the sides. So I would say the ratio of similarity, which we actually call R, is also going to be 2/3. So ratio of similarity is going to be the same as the ratio of the sides. Ratio of perimeters, well, that's still going to be the same as the side length ratio. Ratio of areas, the ratio of areas is going to be R squared. So we're going to take our 2/3 and we're going to square it. Now, as a reminder, whenever we square a fraction, you square the top and the bottom separately. So our area ratio is going to be 4/9.